We're given 5 different numbers. They each have a different base. We need to see which of the 5 numbers has the same value in decimal. Currently, they're given to us in a sort of binary form. So for the first one, we're going to be looking at this. We're going to have a 1, 1, 1, 0, 0, 1, 1, 1. So writing this out first, right here, we have a 1 times 2 to the 0th. That's how we would write that. We're then going to have a plus. We're going to have a 1 times 2 to the first. Then here, we're going to add a 1 times 2 to the second. We can see that we're incrementing the exponent every single time we go up, just like normal. We're going to have a plus. Then here we have a 0 times 2 to the third, or 2 cubed. We're going to have the same thing here because we have a 0, 0 times 2 to the fourth. Then here, we're going to have a 1 times 2 to the fifth. We're adding this. For here, we're going to have a 1 times 2 to the sixth. And then lastly, we're going to have a 1 times 2 to the seventh. Now we just need to add all of these together. And this is going to give us the value of 231. Next, we are going to look at the 2, 2, 1, 2, 0. And this is of base 3 right here. So in multiplying these, we're going to have a 0 times our 3 to the 0th. Here, we are going to have 2 times 3 to the first. Here, we're going to have 2 times 3 to the second. And then here, we're going to have 2, actually, this should not be 2 times 3 to the second. This should be 1 times 3 to the second. And the reason why it's 1 is because we have a 1 here. We multiply by whatever is up here first. Just like in this one, we're going to have a 2 times 3 to the 3. Again, we're incrementing the exponent every single time we go up. And lastly, we are going to have a plus 2 times 3 to the fourth. And we're going to add all of these together when we're done multiplying them together. And this is going to give us 231 as our value. Since we know that the first two numbers are equal to each other, and it says which of the 5 numbers have the same value in decimal, I'm going to highlight these two since they are equal. And now we're going to evaluate the rest of them. We next have a 3, 3, 1, 1, 3 with a base of 5. So this one we had a base of 2, which we noted here. This one we had a base of 3, which we noted right here. And then this one we're going to have a base of 4. So in this one, we're going to have a 3 times our 4 to the 0th power, plus we're going to have a 1 times our 4th to the first power, plus 1 times 4 to the second power, plus 1 times 4 to the third power. I did make another mistake. There should not be a 1 right here. Instead, it should be a 3 because of the 3 right here. So we're going to have the 3, which we always have the 3 multiplying whatever we're given, times a 4. We increment the exponent 3. And that is going to be the value. And from this, we are going to get 215. We can see it's not the same as the others, so we are not going to be looking at it. Next, we have 4110. I'm going to do this over here. We have our 4, we have our 1, we have our 1, and we have the 0. So, and this is for the base of 5. In this one, we're going to have 0 times 5 to the 0th. And here, we are going to have 1 times 5 to the first. And here, we have 1 times 5 to the second. Here, we have 4 times 5 cubed. And this is going to give us the value of 530, not the same of any of the other ones so far. So we're going to go and look at 343 with the base of 8. So this is how we're going to write it out. Now we're going to solve for this by taking our 3, multiplying it by 8 to the 0th, and then we're going to take our 4 and multiply it by 8 to the first. And then lastly, we're going to take the 3. We're going to say 3 times 8 to the second. And this is going to give us a value of 227. Since this is not the same as any of the other ones, we are finished. Only the first two are the same.